So once again, let's just jump into things and get into this review. This is Chapter 5 review. So 8 to the negative 2/3. So we have to simplify this the best we can. The negative sign is going to do something, the numerator has its purpose, and the denominator has its purpose here. So what we got to notice is we have 2/3. We can rewrite this as the cube root of 8 to the negative 2. Now the denominator is always our root, the numerator is always our exponent, and then we just simplify this. The cube root of 8, we can simplify to 2. Negative 2. Now, the negative is going to flip it. So I'm going to have 1 over 2 squared, which is 1/4. So that's the answer to number 1. Number 2 is 81 to the 3/4. It's the same idea, but the difference is I don't have a negative exponent here. So we can rewrite this as a radical by saying the 4th root of 81 raised to the 3rd power. So we look and say, okay, well, what to the 4th gives me 81? It's got to be 3. So this is 3 cubed then. What's 3 cubed? Ooh, it's 3 times 3. 27. Thank you. A lot of people make that mistake. When I ask 3 cubed, most people say 9 immediately, and they're like, oh, shoot, never mind. Okay, 25 to the 1/2. You remember what 1/2 power means? Ooh, no. Just a square root. 1/2 and square root mean the same thing. So what's the square root of 25? 5. That's your answer. We'll go with number 4 now. All right. We have 2 to the 1/4 times 2 to the 5th. What am I supposed to do with these exponents here? I add them. When I'm multiplying two things with the same basis, I add my exponents together. So I need 1/4 plus 5. What's that going to give me?
I got 21 over 4.
21 over 4. You multiply these, and then you add it to the numerator. It's 21 over 4. So 21 over 4 is my exponent, so it's going to be 2 to the 21 over 4. All right, number 5. 5 is the same idea. We have 5 over 5 to the 1/3. This time, I'm not adding things that are like exponents. I'm not multiplying things like exponents. I am dividing. What do I do with those exponents, or like bases? What are the exponents when I am dividing here?
Subtraction.
I subtract them. So I have an exponent here on this top 5. What is that going to be? 1. So I have 1 minus 1/3. That gives me 2/3. So my answer is going to be 5 to the 2/3. Number 6. We have 4 to the 5th over 6 to the 5th, all to the negative 1/5. So what I'm going to do is I'm going to take care of that negative from the start. What does a negative sign do to anything? It flips it. So I'm going to flip this. It's not going to be 4 to the 5th over 6 to the 5th anymore. It's going to be 6 to the 5th over 4 to the 5th. Now this is a positive 1/5 as my exponent. Now, when I have an exponent outside, what I need to do is I need to distribute it to all the exponents inside. So when I do that, this gives me 6 to the 5 times 1/5 just gives me 1. 5 times 1/5 just gives me 1. So 6 over 4, that simplifies to 3/2. Number 7. Number 7 was probably the easiest problem on this page. 9 to the 4th to the 1/9. I'm raising a power to a power. What am I supposed to do with those exponents there? You multiply them. So I have 4 times 1/9, which gives me 9 to the 4/9. Number 4, here, addition. It's adding the exponents together. We had to add those exponents together, so we needed 1/4 added to 5. Gives me 21/4. All right. So we'll go on to the next section. So number 8. I have the square root of 6 times the square root of 12. What's the first thing I have to write down here for this? Square root of what? Square root of 6 times square root of 12. Can I simplify this at all? Can I put these together, yes or no? Yes, I can, because they are both square roots. So what's 6 times 12?
72.
So I need the square root of 72. So what I got to do is I have to look for perfect squares that multiply evenly to get to 72, or divide into 72. So I start at anything less than 72, which is going to be, say, 64. 72 divided by 64 doesn't give me a whole number. Then I go to my next one, which is going to be 49. 72 over 49 doesn't work. What about 36? Yes, it is. So square root of 36 times my square root of 2 gives me 72. Now, what's the square root of 36? 6. So I know this is going to be 6 root 2. Number 9. We have the cube root of 4 times the cube root of 20. Now, can I multiply these together, yes or no? Why? They're both cube roots, okay? So if these are both cube roots, we can multiply them. What is 4 times 20? 80. So this is the cube root of 80. Now we have to use the same idea we used for this last one. What's a perfect cube that multiplies to 80? 8. So this is the cube root of 8 times the cube root of 10. What's the cube root of 8? 2. So this is 2 cube roots of 10. Number 10 follows the same line. I have the 5th root of 486 over the 5th root of 2. Now, first off, are these the same roots? Yes, they're both 5th roots. So if these are the same roots, we can actually perform the division. So when I divide 486 by 2, this gives me the 5th root of 243. What's the 5th root of 243? 3. That's it for that problem. Any questions on the first 10? Okay. Well, I'm going to erase these right now. Amanda, can you get that for me? Want to erase 5? Try to say it either way. Delaney one. Can I erase this now? Can I erase this now? Yeah. All right. So number 11. Number 11, we have the cube root, or the 4th root of 324. So what do I have to look for? Perfect what's here?
Square.
Why squares? What kind of root do we have here?
4.
4. So we have to look for perfect what? 4. So we have to look for perfect fourths in this case. Now, a perfect fourth that goes into 324. Does anyone know what it is? Nope. 16 doesn't go into 324. I would have thought 16 from the start too. But 16 doesn't go into it.
I guess that'd be 81.
It's got to be 81. So 81 times what do you think gives me 324? Let's look at this. 4. Yeah. So if we think of 1 times what gives me 4, and 8 times what gives me 32. That'd be 4. So what's the 4th root of 81? 3. So this is 3 4th roots of 4. What?
It's weird because I didn't think it was this simple. My mind is all the complication.
So 4 over 3 plus the square root of 7. Now, what's wrong with this picture here? What can we have in the denominator? A square root. So I have to multiply by what to get rid of that square root? Not the reciprocal. Reciprocal is the flip.
The conjugate.
The conjugate. We have to multiply by the conjugate. So the conjugate of 3 plus the square root of 7 is 3 minus the square root of 7. Alright. I'll call Bean about this. Now, we distribute here. That's going to give us 12 minus 4 root 7 over when I multiply conjugates, you square the first, you square the second, and you subtract them. So what's 3 squared? 9. What's the square root of 7 squared? 7. And then I have to subtract these. So 9 minus 7 is 2. Last step is to try to see if we can simplify this. Can I simplify 12 and 4 over 2? Yeah, they're all divisible by 2.
6 minus 2 to the square root of 7.
And that'd be my answer for this problem, for number 12. $13 is going to be 27 root 3 plus 7 root 75. Can I add these together right now? No, I can't. Now, a lot of people say yes, and then what they'll do is they'll add the 27 and the 7, the 3 and the 75. You can't do that. We can't add those together because those aren't like terms. They have to have the exact same radicals for me to add them together. So what I have to do then is try to break something down. Now, can I break down 3 to anything else? No. Can I break down 75? Yes. So 75, the square root of 75, is going to be 25 and 3. That's the biggest perfect square, 25. So what's the square root of 25?
5.
That's 5 root 3. That's what this 75 is. So that 7 stays the same, plus 27 root 3. You guys all right with that so far? All we did was break down that 75, didn't we? So then we multiply these together. So I have 27 root 3 plus, what's 7 times 5? 35, thank you. Do these both have the same radicals now? Yeah, they're both square roots of 3. So because of that, I can add my coefficients together and get 62 root 3 is my answer. Now number 14, last one on this front side. We have 7 cube roots of 2 minus cube root of 128. Can I add these together right now? Sorry, can I subtract these right now? No, why not? They're not the same. I have cube root of 2 and cube root of 128. So can I break down this first one? Can I break down the second one? Yes, I can. Thank you. So this is going to give me the cube root of 128, which is going to be the cube root of what times the cube root of what? What gives me 128? What's the perfect cube that goes into it? 64, thank you. And 64 times what? 2. So what's the cube root of 64? Ooh, that's square root. 4. So this is going to be 7 cube roots of 2 minus 4 cube roots of 2, which gives me 3 cube roots of 2. Okay. That's the entire front side. Now the back side. Back side starts off with solving radical equations. Now when I'm solving these radical equations, we have the same 3 steps. What were they? What was the first step always? Isolate the root. After you isolate the root, the second step is going to be, well, not necessarily square. You could have to cube, but it's going to be raise each side to the power of the root. And then the last step is to solve, yeah. So let's start that with number 1. Was it 16, 15? I think it's 15. This is Amanda, I love smiley face. This is Amanda, I love smiley face.
27 days
So
later.
Alicia did that.
Yeah. 27 days left of showing up. Well, in some people's cases, it's more like 6 days left, right? Because they only show up once a week or so, twice a week sometimes, you know. Show up, please. Ooh, yes, you. Both of them have missed a lot. Hassan, you missed a lot. All right. So first step, isolate the root. Is it already isolated? Yes or no? Yes, it is. So in this case, what do I do to both sides? I square both sides. So when I square both sides, I'm going to get 4x minus 7 is equal to, what's 9 squared? 81, thank you. What do I do now to solve for x? Add 7. So 4x equals 88. And then do what? Divide by 4. X is 22. Good job. That was 15. 16. I have 1/2 the cube root of 2x plus 4 is equal to 1. First off, is the root isolated? Yes or no? No, why not? What's there that's not isolated? That fraction. So how do I get rid of that fraction? I can multiply by something to do that. What do I have to multiply by? You said the term earlier. The reciprocal. If we multiply by the reciprocal, that gets rid of the fraction. Now, what's the reciprocal of 1/2? 2 over 1, or just 2. So I multiply both sides by 2, because those cancel now. That gives me the cube root of 2x plus 4 is equal to 2. Is the root isolated now? Yes or no? Is the root isolated? Yes, it is. So what do I do to both sides now? I cube both sides. Thank you. That gives me 2x plus 4 is equal to 8. Okay. How do I solve for x? What do? Subtract 4. That's 2x is equal to 4. What does x equal? 2. So I have to divide both sides by 2. Now 17 is where things start getting complex. 17 is probably one of the hardest problems on this page. So I'm going to have the square root of 44 minus 2x is equal to x minus 10. I can't really see that. Let me write it lower. The square root of 44 minus 2x is equal to x minus 10. Alright. Now, in this case, is the root isolated, yes or no?
Yes.
Yes, it is. So what can I do to both sides?
Raise it to the power, raise it to 2.
Raise it to the power of 2 because we are dealing with square roots. Alright. Now, the left side, what is that going to give me?
X squared times
44 minus 2x. And on the right side, what's that going to give me? X squared minus what? Nope. So when I double distribute this, x squared minus 10, when I multiply that by itself, I have x squared minus 20x plus 100. If you want to multiply it out, you can do x minus 10 times x minus 10. But it's going to give me x squared minus 20x plus 100. Now, do I want to keep everything on the left side or the right side here? Why I say the right side? It does matter. Why do I want everything on the right side as opposed to the left side? So we need our leading coefficient to be positive. So our leading coefficient stays positive when it's on the right side. So what I have to do is subtract my 44 and add 2x to both sides to bring everything to the right side. That gives me 0 is equal to x squared minus 18x plus 56. Yes. Not every question. We have to make sure we isolate the root first. This question, we couldn't do that from the start. We had to multiply by 2. Then we could cube both sides. But for this one, we already have that square root thing by itself, so then we can start like that. So in this case, we have to figure, well, it multiplies to 56, but adds to a negative 18. Now, one of my other classes, what they said is things like, well, 8 times 7 is 56. Yes, that is true. But does that add to 18? No. Now, a lot of people don't know the factors of 56. So what I told them to do is, well, you take 8, you divide that by 2. What does that give you? 4. Okay. Then I'm going to take this 7 and multiply that by 2. That keeps it the same, right? I divided and multiplied by the same thing, didn't it? So what's 7 times 2? 14. Do these add to 18? And they do multiply to 56. So what we can do is say 4 and 14 then. So my solutions here, x would equal what? 4 and x equals 14. Am I done? No. I have to check to see whether these answers work. So I got to plug them back into my original and try to check them out. First, I'm going to plug in 14. What's 14 minus 10? 4. And then 44 minus 2 times 14, that gives me 16. Square root of 16 is 4. This one works. And what's 4 minus 10? No. Negative 6. Now, can I ever get a negative from a square root? No. So just by doing that, we know that 4 is going to be an extraneous answer, and it's not going to be a solution to this problem. We don't need to, because whatever comes out of the square root has to be positive. And we just got a negative 6, didn't we? So we don't need to even check that other side, because we know this got to a negative answer. What? So when I plug a 4 in here and a 4 in here, this gives me 6 equals a negative 6. Does 6 equal a negative 6? No. Because this is negative, and this can never be negative, we know that that's not going to work. So we only had to check one side of that one. And the last one on that section. We have x minus 6 is equal to the square root of 3x. Is the root isolated, yes or no? Yes, it is. So what can I do to both sides? Raise it to the power of 2, I can square it. The left side, what's it going to give me when I square it? X squared minus, what's this times 2? So that's 12x. What's this squared? Plus 36.
Please excuse the
Is
interruption.
that the fourth announcement this hour?
Dominic Kennedy, please report to the second floor office. Again, will Dominic Kennedy
Alright,
please
so we
report
gotta
to the
subtract
second
the
floor
3x
office?
from both sides. We gotta set this equal to 0, then factor. X squared minus 15x plus 36 equals 0. What multiplies to 36 and adds to a negative 15? They're both negative, but what are the numbers? 6 and 6 gives me 12. 12 and 3, oh, good job. So x is equal to 12 and x is equal to 3. When I plug those in, 3 is going to give me a negative answer here, isn't it? Because 3 minus 6 gives me a negative 3. 3 can't work. 12, when I plug that in, I get a 6. When I plug it in here, it's going to give me a 6 also. That's going to work. Any questions here? That was number 18, yes. I'm erasing the left side, though. Don't erase 16. Take a picture of it. It'll last longer. I'm recording a video of this right now. Yes. So I'll be posting the video to YouTube as soon as class is over. Can I erase it now? Okay. Can I erase everything? No? Okay. Now, the next one asks for a couple things. It wants f plus g of x, f minus g of x, and evaluate when x is equal to 4. So it wants that and f plus g of x is equal to 4. So f plus g of 4 and f minus g of 4. These are the 4 things that this question is asking for. So if you don't have 4 answers down, you don't have it right. So the first one, we have f of x is equal to 3 root x. G of x is equal to 10 root x. So the first thing I need to do is I need to add these together. First, can I add 3 root x and 10 root x, yes or no? Why? So inside the radical, the radicands, they're the exact same. They're the exact same roots. So I can add these together. So when I add them, my f plus g of x is going to be just these two added together, which gives me what? 13 root x. And the f plus g of 4 means I'm going to plug in what value for x? 4. So this is 13 square root of 4. What's the square root of 4? 2. So this is 13 times 2, which is 26. So those are the first 2 answers to this one. Now we need the subtraction still. So here's the subtraction. F minus g of x. And it's going to be 3 root x minus 10 root x, which gives me, what's 3 minus 10? So that's negative 7 root x. Now, after that, we have to plug in 4. F minus g of 4. That's going to be negative 7 times the square root of 4. What's the square root of 4? So that's negative 7 times 2, which is negative 14. Okay. So that's that first one. That's number 19. Once again, I told you guys the test is going to be half this length. I'm only going to have one question on there when you're adding and subtracting. Tuesday. What? What sheet? This? If you write everything down, you can have the cheat sheet right here. You can just use everything. Everything has to be handwritten though. You can't have anything typed. What's up? Okay.
I wrote the answers on here, then I wrote that.
You can use anything that's handwritten, one page, as a cheat
Front and
sheet.
back.
So front and back. So if you want to just copy out all the problems from here on a separate sheet, you can do that. The thing is, you still have to know how to do the problems because just having examples isn't going to be everything. Now, next one, f of x is 2x, is that squared? 2x squared plus 3x minus 1. g of x is 4x minus 2. So I need to find the sum, so I need to add them together. So I need 2x squared plus 3x minus 1 plus 4x minus 2. All I'm doing is combining like terms. 2x squared plus 7x minus 3. And I have to plug in 4 for this, because it asks for f plus g of 4. So 2 times 4 squared plus 7 times 4 minus 3. This gives me 32. This gives me 60, that's 57. Then I have to find the subtraction. So that's 2x squared plus 3x minus 1 minus 4x minus 2. What am I supposed to do for this one? I don't like subtraction, so what am I supposed to do for this one?
Change
Change all
the sign, change all the signs in the second equation.
the signs here, so we're distributing the negative and making an addition. That'll give me 2x squared minus x plus 1. What do I have to plug in now for x? 4, thank you. So this is 2 times 4 squared minus 4 plus 1. This is 32 minus 4 plus 1. That is 29. Okay, so that was 19 and 20. We have the multiplication and divisions now. Take your time. Now the multiplication and division problems, they're all about rewriting things. If you can know how to rewrite them, if you know how to write a radical as a fractional exponent and then how to add them from there, that's the way you're supposed to go. So,
Wait.
can I erase the left side? You ever take a picture? Okay.
Oh, right side, blue.
Yep. Now 21, it asks for 21 answer 2. It asks for fg of x, f over g of x, and then evaluate x for whatever x is supposed to be. So first one, f of x is 2x cubed. G of x is the cube root of x, and x is going to equal 2 here. So for this problem, what we got to do is multiply them first. So what I have is 2x cubed times the cube root of x. But you can't actually simplify it right here. What you're going to have to do is rewrite this. I need to rewrite the second one as something with an exponent on it.
Please excuse the
6 announcement.
interruption. Will agent Fleming please report to the second floor office? Again, will agent Fleming please report to the second floor office? Thank you.
So what's my root here? What's my root?
Oh, yeah, 3.
3. What's my exponent? 1. So we have 1/3. So what I'm supposed to do here is add my exponents together. This gives me 2 to the x to the 10/3. And then what am I supposed to plug in here? X is equal to 2. So this is going to be 2 times 2 to the 10/3. You plug it into your calculator, you get an answer back out. I don't know what it is off the top of my head. And I won't be able to tell you. What? No, I don't know. I don't know off the top of my head, guys. I'm sorry. Thank you. Two times 2 to the 10 thirds gives me 20 point. Oh, okay, thank you. So I can actually keep it like this if I want to, or I can write 20 point something. Now, if you wrote it like that, this doesn't actually simplify. You could combine these to get 2 to the 13 thirds, but that's it. It'd be 20.159. Now the division is the exact same thing, but we're going to be subtracting the exponents then instead. So I have 2x cubed over x to the 1/3. That gives me 2x to the 8/3 when I subtract 3 and 1/3. Then I plug in 2. 2 times 2 to the 8/3. I can plug it into a calculator, or I can write 2 to the 11/3.
We still on 21.
Yeah. We have to add and subtract. So we have to multiply and divide. So this is the multiplication, this is the division. Almost done. We have like 3 problems left. F of x is x to the 4th. G of x is 3 root x. And x is going to equal 4 here. Okay, first off, we need to multiply. So that's going to be x to the 4th times 3. And the square root, what's the exponent on that again? You guys remember? Square root, what's the exponent on square root? What? Close. Not 2, but 1/2. How? The denominator is always your root. The numerator is always your power. Square root, exponent 1. Okay. So I add these together. I get 3x to the 9/2. And then we want to figure it out for when x is 4. So this is 3 times 4 to the 9/2, which is 3 times 2 to the 9th. 2 to the 9th is going to give me 512 times 3.
Please excuse the interruption. Will Amir and Kiara T report to the second floor office? Will Amir and Kiara T please report to the second floor office? Thank you.
Is that the 6th or 7th announcement? 7th, okay. That for here, going to divide x to the 4th over 3 root x. Gives me x to the 4th over 3x to the 1/2. Subtract my exponents. That's going to give me x to the 7/2 over 3. X to the 7/2. I plug in 4. So this is 4 to the 7/2 over 3. This is 4 to the 7th over 3. Sorry, 2 to the 7th over 3. What's 2 to the 7th? 2 to the 7th is 128. That's 128 over 3. All we did was use this because we know the denominator means the root. We took the square root of 4. That's how we got 2. And then just simplify. We have 2 more problems, and all they are finding inverses. Now, to find the inverse, you guys remember what steps you need to take? There's only 2 steps, really. First step is to swap your x's and your y's. The second step is to do what? Solve for y. So, for this first problem, we have f of x is equal to negative 2x plus 5. What's another name for f of x? Y. So y is equal to negative 2x plus 5. Then I need to swap them. Thank you. How do I solve for y here? Subtract 5, thank you. Then I do what? Divide by negative 2. Is that difficult? Okay. How about this one? The last one is f of x is equal to 2/3 x plus 2. So when I flip them, what do I get? X equals,
2/3 y plus 2.
what do I do first? Subtract 2. So x minus 2 is equal to 2/3 y. How do I get rid of the 2/3? I multiply by the reciprocal, which is going to be 3 halves. That gives me 3 halves x minus 3 is equal to y. That's it. If you guys have any more questions, this will be posted online. I'll post it immediately. Feel free to email me, send me a text message, phone call, anything. All right?